Given f of x equals x squared plus 6x plus 5, find each of the following: the domain in interval notation, the range in interval notation, the coordinate of the vertex, the equation of the axis of symmetry, the coordinates of the x-intercepts, the y-intercepts, where the function is increasing and decreasing, and finally a graph of the function. So there's a lot of things we need to do here. So let's just get started with what we can find. So beginning with, I'm going to find the vertex first, because the vertex is a really important point and brings together a lot of the other pieces. So to find the vertex, there is a vertex formula, negative b over 2a. We can use that. This looks simple enough to use the completing the square formula on. Either way is fine. So x squared plus 6x plus 5. So 6 divided by 2 is 3. 3 squared is 9. If I add 9 here, I have to subtract 9 over here because I'm working with just one side of the equation. So this becomes x plus 3 quantity squared minus 4. So the vertex is at negative 3, negative 4. So negative 3, negative 4. There's my vertex. Now, I know that this is going to be opening upward, but I don't know exactly where any of the other points are going to lie. So that's kind of where some of these other things are coming in. So let me just write in what I know so far. So the equation of the vertex, there it is, part C. So the vertex was at negative 3, negative 4. All right, now that also gives me the axis of symmetry. So the axis of symmetry is a line that just passes, a vertical line that just passes through the vertex. So it's going to pass through the x coordinate of your vertex. So that means it's x equals negative 3. So I don't really need to do any additional work to get that. Okay, let's work on the intercepts. All right, so the x-intercepts occur where the function itself equals 0. So if I take the function, set it equal to 0, and solve, that's going to tell me where those intercepts occur. So it's going to involve some factoring. 5 and 1 look like they'll work. So x equals negative 5, x equals negative 1, which means my x-intercepts are at the coordinates negative 5, 0, and negative 1, 0. So negative 5, 0, and negative 1, 0. Okay, so there's 2 more points that my graph would pass through. The y-intercept is pretty easy. It's just the constant in the original form here, not the vertex form. So 0, 5. You got to write it as a coordinate pair, though. All right, so 0, 5. You know, that gives me enough to really kind of get a pretty good picture of my parabola here. So I think I can just fill in the information for the rest of them just from the graph. The domain, well, it's a polynomial function. It's defined everywhere, so negative infinity to positive infinity. The range in interval notation, if you'll notice, this function, the lowest point is here at negative 4, and then it's defined all the way up to, positive infinity. So the range here is the set from negative 4 to positive infinity. All right, now, other things we need to fill in. The open interval where the function is increasing. All right, it's increasing on the right side of my vertex. And my vertex is at negative 3, so negative 3 to positive infinity. And it's decreasing on the other side. And that's all the different pieces. So really the only solving is for the X-intercepts and the vertex itself.